Hello there. I am going to walk you through the lab and lab report for lesson 5.06, electromagnetic spectrum. To get started, you're going to come to the landing page and scroll down to find that lesson. Here are the lesson pages for the electromagnetic spectrum. Make sure you're working through those. This lab is going to be one of those where I recommend you have 3 tabs going at the same time. One tab with the lab simulator in the lesson pages, a second tab with the Google Doc forced copy, and a third tab with the video that you're watching right now so that you can watch a bit, pause it, do that portion of the lab, and keep working through it like that. All right, let's get these lesson pages open. Now, again, if you spend your time on these lesson pages really reading and understanding and thinking about the information, you're going to do very well on the lab, and you're also going to do well on the module exam. So make sure you're going through all 5 of those pages, and then when you get to page 6, you will find the directions. Here is the lab simulator, and I'm going to just adjust the size here a bit to fit things in. In this lab, you will use a virtual spectrometer like those found within telescopes or space probes to analyze astronomical bodies in space. Record your hypothesis and spectrometric results in the lab report below. You will submit your completed report to your instructor, me, Mrs. Lohoff. You can use the lab report that's here, or you can use the forced copy that was shown on the previous page. Let me just take you where that is. It will ask you to make your own copy, and then once you do, the first thing I want you to do is share it with me. So if you come down here, here is the Google Doc forced copy. When you open that, the link is right there. It will say, go ahead, click here to make a copy. And when you do, it'll bring you to your own document. Then come right up here to the share button right away, type my name in, Kristen Lohoff, and click done. That way I won't have to kick it back to you saying I need permission to see it. All right, so heading back to this lab. Welcome to the Space and Spectrometry Laboratory. This is where you will begin your investigation of new planets and moons. Select the mission objective icon to learn the purpose of your mission. So we're going to start here. A spectrometer separates a visible light source into its different colors by wavelength. The light source can be anything, such as stars or other astronomical objects. Every object in space releases its own wavelength of radiation. The colors that appear through a spectrometer depend on the makeup of the astronomical object. Different elements absorb different wavelengths of light. This allows for every object in space to have its own spectronomic fingerprint. A spectrometric image of a planet will show a pattern that corresponds to elements present within a planet or star. For example, a planet that contains sodium in its atmosphere will show an absorption line for the wavelength that represents sodium in the spectrum. Scientists can analyze spectrometric patterns to determine which elements are present within objects in space. Your mission is to analyze the absorption. I cannot speak. Your mission is to analyze the absorption patterns produced by newly discovered moons and planets. Holy cow, that sounds complicated, right? We can do it. We can. All right, now we're going to go into the mission prep. It's time for your mission preparation. The image shows a sample absorption spectrum for hydrogen. Notice there is a blank line at, it should be black, a black line at 410 nanometers, 434 nanometers, 486, and 656 nanometers. Radiation traveling through an atmosphere with hydrogen will produce this pattern. A different element will produce absorption lines with different wavelengths. Furthermore, most atmospheres contain more than one element, so the absorption patterns for those atmospheres will be a combination of absorption patterns for the elements that make them up. Your first task is to compare random absorption spectrums to known patterns to identify the element that produced them. For the purposes of this simulation, we will focus on the patterns formed by the absorption lines and less on the values of the wavelengths. When you are ready, press next to continue. All right, so here's our unknown spectrum. This is number 1, and we're going to look for those black lines. Now I see a black line just below the 400 and right before the 450. I see another one before 500, and the next one doesn't come until just after 650. So here's the element carbon and the pattern it makes. Now, right away, I see a purple and a blue, and there's no black lines there, so it can't be carbon. Lithium, there's a purple and a blue, but there's a lot of purple lines, and we don't have the first line until almost the end of the purple section. This one has a line at the end of the purple section, but nothing in the blue. And this has a really heavy line throughout the blue, and our sample doesn't. So if I look, I can see this last one here closely matches our unknown item. So I'm going to click here and guess hydrogen, and it tells me I am correct. Then I'm going to go on to the next one. I think it went on to the next one for me. Here's spectrum number 2. Go ahead and you do the work to compare them. After you've done all 6, I will meet you again. All right, so I finished all 6 of those, clicked the next button, and now we go on to our mission. 4 absorption spectrums are shown below for 2 moons and 2 planets. You can see moon number 1, moon number 2, planet number 1, planet number 2. These were created from the 2 elements present in the atmospheres of the moons and planets. Your task will be to predict which elements are present on each astronomical body's atmosphere. When you are ready, select next. So what you need to remember now, each of these samples is giving us 2 different elements combined into one absorption spectrum. So we're going to have to try and pull them apart. So here's where you're going to do your hypothesis. Predict which elements make up each absorption spectrum and record this in your lab report. So moon 1, you can pick whichever 2 you want. I'm going to pick sodium for everything because I just don't want to give you guys any ideas. I want you to do your own thinking. Once you have done all of this, you're going to make sure you record this in your lab. So in your lab, put your name, my name, the date, the name of the lab. This is the electromagnetic spectrum. In the objective section, I encourage people to wait until the end to write that, because then you can write what you did. Why? What did you learn about? What was this lab? What information was this giving you? And here's the section for the hypothesis. So make sure you copy this information from here into this hypothesis section. All right, and then we are ready to look at the procedure and identify the independent variable and the dependent variable. Remember, the independent variable is what is changing, and actually it asks us to do that at the end. So let's go and click next. Why won't it let me? It's interesting. Maybe because it wants me to do other. Let me go back. I'm just picking any, I'm not putting any thought into it. When you're done, select next. I'm trying to. All right, so I had to go back and redo it. I just finally got it so that next button will activate. In order to determine what 2 elements might be combining, if you click on this question mark, you will see the key, the absorption key for the 6 different elements. And you can look to see which of those are combining in moon 1, which 2 are combining for moon 2, which 2 are combining for planet 1, and which 2 of these are combining for planet 2. Once you have your hypothesis done and recorded in your lab report, let's go on. Now, we're going to select the 2 that go for moon 1. We have to look to see which two are being combined. Now when you look at the patterns here, you're going to figure out which two of these below are combining to make this image. It's not sodium. It looks like we could have some lithium here when I look at the pattern. And I think maybe carbon. All right, I got the two. Now I need to come up into the table and I need to put the two that I had. They were, can't remember, carbon and I think it was lithium. So I put in yeses for the ones. Oh, and it won't let me go back. I hope I recorded that accurately. Moon number 2 is definitely sodium and nitrogen. Yes, sodium and nitrogen. Sodium and nitrogen. So sodium and nitrogen. So you put in yes or no as to if those elements were visible or not. Then you're going to keep working through those. I'll meet you at the other end. All right, once you have completed all of those activities with which elements are combining, you're going to make sure that your data table here in the lab matches what you found. Then it's asking some questions, and it's going to jump up and talk about this independent and dependent variable. If you viewed multiple unknown astronomical objects you have viewed multiple unknown astronomical objects in this lab activity, in all tests, what was your test variable? What was the thing that changed? The independent variable is what we changed each time. Did we change the amount of an element in an object? Did we change the types of elements in each spectrum? Or did we change the astronomical object viewed by the spectrometer? So come up with your answer and record it here, and then record it in the lab under your independent variable. And then I'll meet you back for the next one. The next question is about the dependent variable. You have viewed multiple unknown astronomical objects in this lab activity. In all tests, what was your outcome variable or the dependent variable? That's what you measured. What were we measuring or counting? Were we counting or measuring the amount of material used in each test? Were we measuring or counting the spectrum of each astronomical object? Or were we counting and measuring the type of object that created each spectrum? Pick your answer and record it in the lab under the dependent variable. And I'll meet you at the end of this one. All right, then keep working through the rest of the questions in that lab report or in the simulator, and then you can come into the conclusion. Make sure that you're answering all, I believe there are five, sorry. Make sure you answer all 5 questions using the information you gathered. This is not a place to Google and copy and paste from the internet. Your answers need to be based on the information you got in the lab. Refer back to that data table. You're putting the data table into written form. Once you're done with that, come back up to that objective session. And what was the whole point of this? What were you learning about? If you have questions, you can reach out to me by email, you can book an appointment, or you can leave a voice message on my phone line, and I am more than happy to get back to you. Good luck. I look forward to seeing these.